Hello everyone, welcome back to Tejuma YouTube channel. Let us solve few more questions based on Coulomb's law topic. So here we have the question that is 4 charges minus q each are placed at 4 corners of square and charge small q is at its center. For equilibrium, the value of small q should be. So if I consider a square here, so consider 4 charges minus q minus q minus q minus q each are placed at 4 corners of a square and a charge small q is at its center. So there is a charge small q at its center. For equilibrium, the value of small q is. So in equilibrium condition, the net force acting on any one of the charges will be 0. Let's consider the force acting on small q at this placed at one of its corners is 0. That means here how many forces are acting? Let's consider minus q repel each other. That is force. If I consider this is A, this is B, C, D. Force between AB will be in this direction. Force between BC will be in this direction. And force between BD will be in this direction. BD. Correct, no? Now, to balance this, we have small q, so that will be acting in this direction. That is the force by small q charge on capital Q charge. So when these get balanced, you will get 0 force, or net force is 0 on capital Q. So first I will find the resultant of this one. So FAB value is equal to FBC value, because the charge and the distances are same. That is equal to some constant k, that is 1 by 4 of epsilon naught, capital Q into capital Q divided by a square. So this FAB is equal to FBC in the direction of BD is given by F. Let me calculate that. That is F is equal to square root of FAB square plus FBC square. So that will be equal to square root 2 times this value k capital Q into capital Q divided by a square. Just substitute this here, you will get the answer. This is one force. So that F plus FBD is given by F plus FBD is equal to F is k root 2 q divided by a square. FBD is k capital Q into capital Q, same q divided by distance. What is the length of the diagonal? It is root 2 times a whole square. So you will get 2a square. So this is the force acting on the charge due to other 3 charges which are at the corners. Due to charges at corner, that is capital Q charges. What about one more charge, small q? So that also exerts some force on capital Q. That is k capital Q small q divided by, so a divided by root 2 whole square. That is the half of the diagonal. Complete diagonal is root 2 into a divided by 2 will give you a by root 2. Root 2 square is 2. That is 2k small q capital Q divided by a square. Now we know that F small q into capital Q is equal to F capital Q, no, F plus FBD. So if you equate those two, what do you get? you will get um, 2k small q capital Q divided by a square is equal to, here in this what is the common thing, k is common, q into q square divided by a square is common, remaining root 2 plus 1 by 2 is there. So capital Q get cancelled, a square k get cancelled. What we need to find out? The value of small q, right? So k get cancelled, small q I will write here, small q will be equal to capital Q divided by 2 into root 2 plus 1 by 2. So but here capital Q is negative, I'll write minus sign here. So capital Q is negative, so to attract small q should be positive, so that's why I will get positive value only. Yeah, so capital Q by 2 into, so this answer where do we have small q is equal to q by 2, so we need to simplify this further. I think q divided by 2 to the 4, 1 plus 2 root 2 divided by 2 to the 4. So we have this answer in option B. Okay, this is about this question. Let us move to the next question. So two spheres having electric charges 2 nanocoulomb and minus 8 nanocoulomb are placed at a distance small d apart. If they are allowed to touch each other, what is the new distance between them to get the repulsive force of the same magnitude as before? So let me consider two spheres having charges q1 q2 separated by distance r. F is equal to k, q1 is 2 nanocoulomb, q2 is minus 8 nanocoulomb. I will take just magnitude divided by they are present at a distance small d whole square. So then if they are allowed to touch each other, so then their charges will become q is equal to q1 plus q2 divided by 2, that is minus 8 plus 2 is minus 6 divided by 2 is minus 3 nanocoulomb each. Then F dash will be the force should be same but distance should be different, right? Yeah, to have the same force, so what should be the new distance to get the same repulsive force? So F is equal to k, q1 is 3, q2 is 3, minus to get cancelled, so divided by d dash square, or let me consider it as r square. So since these two forces are same, I will equate these two, so then k get cancelled, so then we'll be having 2 into 8 divided by d square is equal to 3 into 3 divided by r square. So if I take square root on both sides, I will get root 2 into 8 to the 16, 4 divided by d is equal to 3 divided by r. Therefore r is equal to 3d by 4. Option D is correct. Right? So now we'll move on to the next question. Two pith balls carrying equal charges are suspended from a common point by strings of equal length. The equilibrium separation between them is r. Now the strings are rigidly clamped at half the height. The equilibrium separation between the balls now become. So we need to find out the value of r dash. So here two pith balls are there. They are having the equal charge. Let me consider it as small q. So here the distance is r between them. So there are three different forces acting on them. I will write them later. Now if these two strings are clamped at this particular height, so that is equal to y by 2, even this will be y by 2, then what will be this r value, or I can consider it as r dash also. So let us consider here we have this angle is theta. So there will be force acting here, that is mg. One more force acting in this is tension. So along y axis here, upward force will be t cos theta, because this also will be theta, and in this direction t sin theta. So electrostatic force of repulsion will be there, Fe. So from this I can get, can I take Fe is equal to t sin theta, and or t sin theta is equal to Fe. The forces along x-axis balanced, and forces along y-axis is t cos theta is equal to mg. And if we divide these two, what do you get? Sin theta by cos theta is tan theta, that is equal to Fe divided by mg. I am just dividing. Fe is Coulomb force, that is k q square by r square into mg as it is. So here the constants are, so that is equal to k is constant, m is constant, g is constant, charge is also constant, r is the distance between the charges here. Now if you consider this triangle, tan theta is equal to what? Opposite by adjacent. Opposite is r by 2 divided by adjacent is y. So from this, if you consider y value, that is equal to r mg into r square is r cube divided by kq square. So from this what you get? Y is directly proportional to r cube. So y is equal to some constant into r cube. So if you vary the y value, r value also varies like this. So y value is varying by how much? Y by 2, that is equal to c into r dash cube. So if we divide this equation 2 by equation 1, what do you get? Y by 2 divided by y is equal to c r1 cube divided by c r cube. So y get cancelled, c get cancelled. So r dash cube divided by r cube is equal to 1 by 2. Take cube root on both sides, you will get r dash is equal to r divided by cube root of 2. So which option is correct here? Option A is correct. That is option A. So moving on to the next question. So here two metallic spheres are there. One is having the radius 1 centimeter and another one is having more radius, that is 3 centimeter. Are given a charge q1, that is minus 1 into 10 to the power minus 2 coulomb, and q2, that is 5 into 10 to the power minus 2 coulomb respectively. These are connected by conducting wires or wire. The final charge on the bigger sphere is, let me consider charge on the smaller sphere is qs, charge on the bigger sphere is qb. So when they are connected, the total charge will be equal to charge on smaller sphere plus charge on bigger sphere. So that will be sum of these two charges, q1 plus q2. 5 minus 1 is 4 into 10 to the power minus 2 coulomb. So initial charges are small q, final charges are capital Q. Okay. Now since their radii are different, Qs will not be equal to Qb. Therefore I will take the formula of Q, which is directly proportional to C, which is directly proportional to radius. So that is Qs by QB is equal to RS by RB. That is equal to RS is small is 1 centimeter, radius of bigger sphere is 3 centimeter. Therefore QS is QB divided by 3. So if I substitute that one here, QS is QB divided by 3 plus QB, which is equal to 4 10 to 10 to the power minus 2 coulomb. So QB 3 1s are 3 plus 1 is 4 QB, which is equal to 4 3s are 12 into 10 to the power minus 3 coulomb. So 4 3s are 12. So QB is equal to 3 into 10 to the power minus 3 coulomb. So that's why option B is correct. So when they are touched or connected, so here we need to take potential on smaller sphere is equal to potential on bigger sphere, because there is a distribution of charges here. The charge is different but potential will be same on the surfaces. Okay, so from that we get this one. Moving on to next one. An electron is revolving around or moving around the nucleus of hydrogen atom. So actually this is 11th question. Hydrogen atom in a circular orbit of radius r. Let me consider here there is a nucleus of hydrogen whose charge is E, and electron is revolving around it whose charge is minus E. Whose charge is minus E. The electrostatic force is K Q1 Q2 divided by r square. R is the radius. So F is equal to K, Q1 is E, Q2 is minus E divided by r square. So we'll get F is equal to K E square divided by r square with minus sign. So since this option is not there in this, because here plus sign is there, actually we should have minus sign there. So if you write this in vector form, what do you get? Minus K E square by r square into r cap. So this option is also not there, or you can also write it as minus K E square into r cap is given by r vector divided by r into r will become r cube. Correct now, since r cap is given by r vector divided by r, that is a unit vector. So that's why option D is correct. So moving on to the last question. When air is replaced by dielectric medium of force constant K, the maximum force of attraction between the two charges separated by distance is. So if you consider air is replaced by dielectric medium of force constant K, the maximum force of attraction between the two charges is attraction or repulsion. So if you consider here, the formula for that 1 by 4 pi epsilon naught into Q1 Q2 divided by r square. This is the maximum force. If you introduce the dielectric constant K, then F decreases by an amount K. Therefore option A is correct. So this is all about this topic, that is Coulomb's law. So next video will be based on one more topic, where I will solve more number of questions, relevant questions on that particular topic. So if you feel these videos are useful, please share it to your friends and keep practicing. All the best for your examinations.